Okay, in our next example, we have another higher order polynomial equation, and we could get as many as 5 answers from this polynomial equation. Once again, the only way that we know to solve these is to get everything on one side, factor, and then apply our zero product property. So I'm going to begin by adding 1,250 x squared to both sides. So now my problem is 10x to the 5th plus 1,250 x squared equals 0. Now let's factor, okay? Now, you might notice that everything is divisible by 10. That's great. And everything is divisible by x squared. However, you never want to divide through by the variable that you're solving for. I only want to divide everything through by 10. So now I have x to the 5th plus 125 x squared equals 0. If I would divide everything through by x squared, that would eliminate one of my answers, and I need 5 answers. That would take that down to a degree 3. All right, so now, again, start with the factoring. The first thing I'm going to consider is there a greatest common factor in each of these terms, and you will see that there is a common x squared in both of those. So I'm going to pull that out and write the leftovers, x cubed plus 125. Bring down the equals 0. Now you know we're at the point here where we have a factor times a factor equals 0. Set each of these factors equal to 0 and solve. So I'm going to write x squared equals 0, and then x cubed plus 125 equals 0. Over here on the first one, solving for x, really, the only thing that's going to satisfy that is going to be 0. If you want to apply your square root property to both sides, feel free to do that. You would have x is equal to positive and negative. Square root of 0 is just 0. So actually, we just get x is equal to 0, but we say with a multiplicity of 2 because it happens 2 times. So we have x equals 0 and x equals 0. We have 2 answers down, 3 more to go. Now, if your equation is higher than degree 2, it's possible that you need to factor this to find all of your solutions. Now, at first glance, x cubed plus 125 may not look like it factors, but believe it or not, it does. It is one of those special products called the sum of 2 cubes. Sum of 2 cubes. We had a formula to factor the sum of 2 cubes back in review section 5. And we had a formula that said, if you're trying to factor some quantity being cubed plus another quantity being cubed, that thing will factor into a plus b times the quantity a squared minus a times b plus b squared. Wow, okay? We're going to use that formula where the a is the first quantity being cubed, the x in this case, and the b is the second quantity being cubed, and that's going to be a 5 because 5 cubed does indeed give us 125. 5 times 5 times 5 is 125. So x cubed plus 125, I'm going to use my formula up here, factors into x plus 5 times x squared. Then there's a minus sign in the formula Here we're going to do x times 5, which we know instead of writing x times 5, it always looks prettier to write it in the other order, 5 times x. And then the formula says plus b squared. So plus the 5 squared is going to give us plus 25. That, believe it or not, is x cubed plus 125. And if you want to pause the video now and multiply that out by running the x through everything and running the 5 through everything, combining like terms, if you do everything correctly, I bet you $5 you're going to get x cubed plus 125. So that is how that would factor. If you want to pause the video, you can do that. Now, I'm going to move all that mess out of the way. Let me get rid of that. Eraser, eraser. The whole reason we did that is because now we are at the point that we love where we get a factor times a factor equals 0. So to solve this, we set each factor equal to 0 and attack solving these remaining equations. So x squared minus 5x plus 25 equals 0. Okay, so far in our solution set, we know we have x equals 0. Now, subtracting 5 from both sides, we're going to have x is equal to negative 5. And this quadratic equation is going to give us 2 more solutions. Now, we do want to consider if it will factor. So I'm looking for 2 numbers that multiply to give me the 25, but that add or combine together to give me a negative 5, and I can't see how that will factor. But don't worry, you know, we do have our quadratic formula. All right, solving that quadratic equation by using the quadratic formula, we're going to get x is equal to negative 5. There's my negative, whoops, I forgot to write the negative 5, negative b plus or minus the square root of the b value squared. Negative 5 squared is positive 25 minus 4 times the a value of understood to be 1 times the c value of positive 25 all over 2 times a. 2 times 1 is just 2. Let's clean this up a little bit. So we're going to have the opposite of b is a positive 5 plus or minus the square root of something all over 2. And that something we're going to get in there is 25 minus 100 is 4 times 1 times 25. So we get negative 75. Okay? Now, I really think we can break down negative 75. We know it's the same thing as I times the square root of 75, right? All over 2. That's how we break down the negative part of it. But 75 does have a nice little factor that is a perfect square. 75 is 25 times 3. So the best way to write our, simplified form of this is 5 plus or minus, I'm going to write this as 5i square root of 3. And then it's all over 2. So I'm actually going to have 4 unique elements in my set, but actually I do have 5 solutions. 0, remember, just occurred 2 times. So my solution set is as follows. The 0, the negative 5, and then I think I want to write these separately. I just feel like writing these solutions here separately. And you'll notice we have complex conjugate solutions here. The first one is 5 halves plus 5 square root of 3 over 2i. And the last one is 5 minus 5 square root of 3 over 2i. There's the entire solution set. 4 elements, 4 unique elements in this degree 5 equation. Again, get everything on one side, factor.